Here are the answers for the section 6-1 homework. On page 211, the orals, we're given some ordered pairs in a set, and we're asked for the domain and range. To do this, we need to know what domain and range mean. Domain is a list of the first coordinates. Often those are the x-coordinates. The range is a list of the second coordinates in the ordered pairs. And often those would be your y-coordinates. In question number 1, we have 3 ordered pairs. Each of them has an x and y coordinate. To give the domain, we're making a list of numbers, so we should include that list in braces. We want to list all of the x-coordinates. There's a 1 and a 2 and a 3. To give the range, we're going to list all of the y-coordinates. There is a 1, a 2, and a 3. For number 3, let's do the same thing. First, let's identify the first and second coordinates each time. It is common to call them x and y. X, y, x, and y. The domain is a set of all of the x-coordinates. There is a 1 from over here, there is a 2, and there is a 3. The range is a list of all of the y-coordinates. They're all -1. You only need to list the number once. Number 5. Let's first identify the first and second coordinates each time. I'm going to call them x and y. The domain is a list of all the first coordinates in the set. Another way to say that is all the x-coordinates. There's a 2 and a 3. The range is a list of all the second coordinates, the second numbers in the parentheses. There's a 1, a 2, and a 3. For the written, we're asked to figure out the range if we use this as the domain. So we're not going to use every number for x. Instead, we're going to use these 7 numbers as our values of x, called the domain. Once we know what the range is, then we can make our graph. So in number 1, we want the set of ordered pairs x comma y such that y is equal to x minus 1. This equation gives us a rule to find the value of the range when we plug in a number from the domain. We have done this in an earlier chapter. So I've already created my table to keep everything organized. And let's follow that rule. Y equals, where the letter x is, substitute -3, and then -1, and this turns out to be -4. When x is -3, the value of y is -4. When the value of the domain is -3, the value of the range is -4. Let's do this for every row. Plug in the x-coordinate and then -1 from it. Plug in the x-coordinate and then -1 from it. And so on, working our way down the column. We're asked to give the range. I'm going to write that right here on the paper. The range is a list of numbers. We should put that list inside of braces. It is a list of all of our y-coordinates. -4, -3, -2, -1, 0, 1, and 2. When x takes on these 7 values, y takes on these 7 values. Now we're asked to graph this. We have -3, comma, -4. So left 3, and then down to -4. Next one, -2, comma, -3. So left to -2, and then down to -3. Next row, -1, comma, -2. So left to -1, and then down to -2. Next row, 0, comma, -1. Right there. Next row, 1, comma, 0. That's right here. Do you see the pattern of the dots? We know from an earlier chapter that this is a linear function. Number 3, we have the set of ordered pairs x comma y such that the y value is greater than or equal to x minus 2. I've already made a table to keep things organized. Now let's substitute our values of x. This first one ends up as y is greater than or equal to negative 5. Next row of the table, let's substitute negative 2 for x. This one ends up being y is greater than or equal to negative 4. And let's continue like this, working down the table. Do you see a pattern yet so that we can save some time and not show so much work? This next one will be y is greater than or equal to negative 2. This next one will be y is greater than or equal to negative 1. This next one will be y is greater than or equal to 0. And the last row turns out to be y is greater than or equal to 1. Now we can get our range. The range is a list of all of the y values generated by the relation. That should go in braces. When we think about all of these statements, we can write this as a single expression. Y is greater than or equal to negative 5. Now let's make the graph. When x is negative 3, y is greater than or equal to negative 5. Here's where x is negative 3. Let's go straight down until we get to negative 5. And mark that with a closed dot. Now, it doesn't say that when x is negative 3, that y only equals negative 5. It says that y is anything greater than or equal to negative 5. To show that, you draw a vertical line coming up from that endpoint dot. And draw an arrow on it to show it continues upwards forever. Next row of the table, when x is negative 2, y is greater than or equal to negative 4. Here's negative 2, and then go straight down till you get to negative 4, and mark that with a closed dot. But then show everything greater than negative 4 by drawing upwards and putting an arrowhead on the end. Third row, when x is negative 1, y is greater than or equal to negative 3. So here's where x is negative 1, then come straight down till you get to where y is negative 3, and mark it with a closed dot. Then show everything that's greater than negative 3 by drawing upwards with an arrowhead. Next row, when x is 0, y is greater than or equal to negative 2. That closed dot is right here. And then draw upwards, tracing over the y-axis with an arrowhead. Do you see the pattern so that we can save a little bit of time? There'll be a dot here, and a ray coming upwards. There'll be a dot here, and a ray coming upwards, and a dot here, and a ray coming upwards. Number 5, the set of ordered pairs x comma y such that y is always equal to 2. So no matter what x is, y is equal to 2. So when x is negative 3, y is equal to 2. When x is negative 2, y is equal to 2. And so on all the way down this chart. Now let's give our range. Range is the set of all values for y. In this case, it's only the number 2. Now let's graph. When x is negative 3, y is 2. When x is negative 2, y is 2. When x is negative 1, y is 2. When x is 0, y is 2. When x is 1, y is 2. Do you see the pattern? These 7 dots are the graph of this relationship. Number 7, we have the set of ordered pairs where the first coordinate is called x, and the second coordinate is found by taking the negative of the absolute value of x. I've made my chart. Now let's substitute our number in for x and evaluate the answer. The absolute value of -3 is 3, but then there's a negative in front, making -3. Next row. The absolute value of -2 is 2, but then there's a negative in front, making -2. Next row. This turns out to be -1. The next row. This turns out to be 0. The next row. The absolute value of 1 is 1, and then there's a negative in front of that. The next row is -2, and the final one is -3. Now let's give our range. The range is the set of all of the second coordinates in the relationship. We got -3, -2, -1, and 0. And then they started to repeat. But when you list the range, you don't have to list repetitions. Now let's make our graph. When x is -3, the value of the range is -3. So left 3, down 3. When x is -2, the value of the range is -2. Left 2, down 2. When x is -1, the value of the range is -1. Left 2, down 1. Next we have 0, 0. Next we have 1, -1. Then 2, -2. And then 3, -3. So these 7 dots are the graph of this relationship. Number 9, the set of ordered pairs x, y such that x plus 3y is greater than 4. I've set up the table. Now we need to find y. We know from an earlier chapter that it's easier to find y if you change this to slope-intercept form. So let's subtract x from both sides and then divide by 3. Now we can solve for y. Y equals 4/3 minus -3 over 3. Let's figure out this answer. A negative changes to plus. 4 plus 3 is 7/3, and this is the mixed number 2 and 1/3. Second row of the table, y equals 4/3 minus -2 over 3. Minus a negative makes plus. 4 plus 2 makes 6, and 6 over 3 makes 2. Next row of the table, y equals 4/3 minus -1 over 3. A negative makes plus. 4 plus 1 makes 5 over 3. And this is 1 2/3. Do you see the pattern so that we can save a little bit of time? This next row would turn out to be 4/3, which as a mixed number is 1 1/3. This next row turns out to be 3/3, which is 1. This next row would turn out to be 2/3. And the last row would turn out to be 1/3. Now let's give the range. I'll write that up here. It is a list of numbers, so I'm going to put it in braces. What numbers did we get for our y values? The smallest number we ever got was 1/3, then 2/3, then 1, then 1 1/3, 1 2/3, 2, and then 2 1/3. When x takes on these 7 values, y has these 7 values. Now let's graph our ordered pairs. -3, 2 1/3. Here's -3. I'm going to go up to 2, and then an extra 1/3. -2, 2. is located here. Negative 1, comma 1 2/3. Here's negative 1. I'm going to go up to 1 and then an extra 2/3. 0, comma 1 1/3. Here's 0. Go up to 1 and then extra 1/3. 1, comma 1 is located here. Do you see the pattern? Just kind of extend it coming downwards in a straight line. Number 11, the set of ordered pairs x comma y such that y equals 2 times the absolute value of x plus 1. This equation already has the y alone, so we don't need to rearrange anything. Let's fill in our chart. Y equals 2 times the absolute value of negative 3 plus 1. And figure out what this makes. Negative 3 plus 1 is negative 2. The absolute value of negative 2 is positive 2. And 2 times positive 2 is 4. Next row. Fill in negative 2 for x. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is positive 1. And 2 times 1 is 2. Next row. Fill in negative 1 for x. This answer is 0. Next row. Fill in 0 for x. This answer is 2. Do you see a pattern starting to develop? This next one will be 4, the next one will be 6, and the next one will be 8. Now let's give our range. What did we get for y? Our smallest number is 0, then 2, then 4, 6, and 8. Let's graph our ordered pairs. First row, negative 3, comma 4. Second row, negative 2, comma 2. Third row, negative 1, comma 0. Fourth row, 0, comma 2. Then 1, comma 4. 2, comma 6. And 3, comma 8. This mark up here was 8, this mark here was 6, and so on. Number 13, the set of ordered pairs called x and y such that y equals x squared. This already has y alone, so we're ready to make our table. Fill in negative 3 and square it. That makes 9. Fill in negative 2 and square it. That makes 4. Fill in negative 1 and square it. That makes 1. Fill in 0 and square it. That makes 0. Fill in 1 and square it. That makes 1. Do you see a pattern starting to develop? This makes 4. This next one makes 9. Let's get our range. What are all of the second coordinates, all of the y values? We had 0, 1, 4, and 9. Now let's graph. Negative 3, comma 9 is located up here because this is the 9th mark up. Negative 2, comma 4 is located here. This is the 4th mark up. Negative 1, comma 1 is here. 0, comma 0 is here. Here's 1, comma 1. Here is 2, comma 4. And here is 3, comma 9. Number 15. The set of ordered pairs x and y such that this inequality is true. Let's substitute our value into that inequality. Where the x is, put in negative 3. This makes 0 is less than or equal to y, which is less than or equal to 9 halves. 9 halves is the same as 4 1/2. Okay, next row. Let's fill in negative 2 where the x is. And see what this makes. 0 is less than or equal to y, which is less than or equal to Negative 2 squared is 4, and 4 divided by 2 is 2. Okay, the next row. Fill in a negative 1 where the x is. And now simplify. 0 is less than or equal to y, which is less than or equal to. Negative 1 squared makes 1, and 1 divided by 2 is a half. Next row. Fill in 0. And let's see what this makes. 0 is less than or equal to y, which is less than or equal to 0. What is this really saying that y is equal to? This really means y equals 0. Next row. 0 is less than or equal to y, which is less than or equal to 1 squared over 2. And this makes 0 is less than or equal to y, which is less than or equal to 1/2. Are we starting to get a repeating pattern? This next one is going to turn out to be 0 is less than or equal to y, which is less than or equal to 2. And this next one is going to be 0 is less than or equal to y, which is less than or equal to 4.5. Now let's give our range. I'll write that up here. What kind of y values did we get? Now let's graph. X is negative 3 is located right here. And the values of y are everything between 0 and 4.5. So let's put a closed dot here at 0 and then go straight up to 4.5. This is 4 and this is 5. So 4.5 is going to be exactly halfway between 4 and 5. And then we want to make this as a segment. When x is negative 2, that's this mark here, y is between 0 all the way up to 2. When x is negative 1, that's this mark, y is between 0 and a half. When x is 0, y is 0. Now we start to repeat our little segments. So there's that short one. Here's the segment that goes up 2 units. And here's the segment that goes up 4.5 units. Now that we see a visual representation of the relationship, we might go back to the range and redo that, because I think I can describe the kind of y values I'm seeing. The smallest y value we ever have is 0, and it seems to go up to a height of 4.5. So I think this description here describes the different y values showing in our graph. Number 17, graph over the set of real numbers. So this time we're not limiting our domain to negative 3, negative 2, negative 1, and so on. We're using all real numbers as the domain. You have done this in an earlier chapter. Do you recognize this kind of equation? We're used to the letters being x and y, but it is still a linear equation. We know different ways to graph this. We could make a table with some ordered pairs. We could put this in slope-intercept form, or we could use intercepts method. I'm going to choose intercepts method. We're used to finding the x-intercept and the y-intercept. It's just this time we have the a-intercept in the b-intercept. So let's get our intercepts. 2a plus 5 times 0 is equal to negative 10. Therefore, 2a is equal to negative 10. A is negative 5. On the a-axis, there's a dot at negative 5. We're used to that being the x-axis. It's just this time, it's the letter a here, not x. Let's get our other intercept. 2 times 0 plus 5b equals negative 10. 2 times 0 is just 0. So this is 5b equals negative 10. Therefore, b is negative 2. So on the b-axis, there's a dot at negative 2. Usually we call that the y-intercept. This time it's the b-intercept. Because we're graphing for all real numbers, we're going to draw a line through the dots. If we weren't doing all real numbers, if we were graphing just integers like every other question, then we would have individual dots in there, but no line drawn through them. So this diagonal line is the graph of this relationship between the letters A and B.